Okay, so page 99 of your notes. We've got two properties to look at today involving cyclic quadrilaterals. So 9.4. And today's date is the 25th. Right. Alright, so with your notes. Alright, so cyclic. So we've got, first thing we need to talk about concyclic points. These are points that lie on the circumference of the same circle. So points A, B and C we call concyclic. They lie on the circumference of the circle. So any three non-collinear, okay, non-collinear means they all are in a straight line. The non-collinear means they're not, okay, any three non-collinear points are concyclic, okay. So take points A, B and C. If you put any three random points, okay, you can actually form a circle through those 3 points. Okay, so they lie on a unique circle, the centre, which would be the point of intersection of the perpendicular bisectors of the interval. So if I do A, B and C, join them up halfway, perpendicular, till they meet at a common intersection point, and that will be the centre of that circle. Okay, so I'm not going to say too much more about that, but that's something to keep in mind. Alright, so a cyclic quadrilateral is a quad which has 4 concyclic points. Okay, so we've got A, B, C, D for example. Alright, so we have that type of quadrilateral. Now there are a couple of properties that we're going to look at involving the cyclic quadrilateral. So number 9, we have the opposite angles of a cyclic quadrilateral are supplementary. Okay, supplementary means add 180 degrees. So if we have the angle x here, this is going to be 180 take away x. And we've got angle y at the top, and this angle opposite it is going to be 180 degrees take away y. Okay. Right, so the converse is also true. So if the opposite angles of a quadrilateral are supplementary, then the quadrilateral is a cyclic quadrilateral. Right, so let's have a look at a proof. Okay, so we want to prove so 9.9 we're up to. Okay, so again, the syllabus requires you to know the proof, okay, but it's more important when you're doing deductive reasoning, okay, so when you're going to prove certain angles and certain sides, etc., etc., in a general problem, and we'll look at that once we've gone through the proof. Okay, so we have a cyclic quadrilateral A, B, C, D, okay, because they're points that lie on the circumference of the same circle. Alright, so we've got the centre point of the circle, and we've joined the interval BO and OD. Alright, and then from a previous property, if we had the angle here 2x, then we had the angle down here of x. The angle here 2y, we had the angle here of y. Okay, remember, angles at the centre is twice the angles at the circumference. Okay, so this is y, the angle at the centre will be 2y, and this is x, the angle at the centre will be 2x. Okay, so let's set it up formally. So let angle BOD equals to y. Now, this 2x angle is also notated as angle BOD. Whenever you notate an angle, you're always referencing the obtuse angle. Alright, so one that's less than 180 degrees here. when you've got the reflex angle, okay, you need to say the reflex angle BOD, and that's going to be 2x, okay? So same angle, but I'm referring to both the obtuse and the reflex part of it. You need to make sure you're stating the reflex if you're showing a reflex angle. Right, so angle, let's go BAD is going to be Y, and angle BCD will equal X. Okay, let's write our reason. Angle at centre is twice angle at circumference. Okay, so these things we already know. Right, what can you tell me about 2x and 2y? What about 2x plus 2y? What can you tell me about that? Good. Okay, so we've got the total revolution angle there. 2x plus 2y. So we know that 2x plus 2y must equal 360 degrees. The reason, angles at a point adds to 360 degrees. Right, so that's another thing on unknown. I want to then show the angle Y and angle X, when I add them together, they are supplementary. In other words, when I add X and Y together, I get 180 degrees. Can anyone see how we're going to show that? Alright, so 2x plus 2y equals 360. Take the 2 out. So, lots of x plus y equals 360. Nice and simple. So we know that x plus y must equal 180 degrees. So therefore, angle BAD, angle BAD, plus angle BCD must equal 180 degrees. Right, so these two angles equal 180 degrees. Okay, so there's a couple of things I can do now. I need to actually show that the angle here and the angle here, these two angles add to 180 degrees. I need to now show that these two angles here and here also add to 180 degrees. There's a couple of simple ways I can do it. How can I do it?
Something involving the radius.
Sorry?
Something involving the radius.
Yeah. Okay, we can actually set this up similar to how we proved these two angles. So if I actually dotted the lines here and here and call that 2M and 2N, I can then do a similar proof to going back there. Okay, but what's another way I can actually show that those two angles at B and D must also equal 180 degrees? What's the angle sum of a quad? Any quadrilateral. So the angle sum of any quadrilateral because any quadrilateral can be made from two triangles, and we know that sum of the angles in any triangle you form is 180. Okay, so that means if you join two of them together, they will equal the angles, or four angles will equal 360 degrees. Okay, so which implies the angle ABC plus angle ADC must equal the angle sum of our quadrilateral minus our other known angle. And we know that these two angles, we've just proved it, equals 180 degrees. Okay, so therefore, those two angles must add to give 180 degrees. Okay, so nice and simple there. So therefore, opposite in a cyclic okay, this is a property that comes up a fair bit. Okay, good thing it's a fairly straightforward one. Because there's a couple coming up involving chords that are not so obvious first up. Okay, question. That was number 9. Okay, so if we're going to show the converse, we can do a very similar proof to what we've just done to show the converse. So I'm not going to go through that. I'm going to look at the next property. A couple of example questions, and then you've got the rest of the morning to do some work. Okay, everyone done? Alright, so that's number 9. Number 10. The exterior angle. Okay, so when we refer to an exterior angle, it means we extend a side of your triangle or your quad, whatever polygon you've got. You extend that side, and the angle it forms from the extension back to another side, that's what's called the exterior angle. Okay, so the exterior angle of a cyclic quad equals the interior opposite angle. Okay, so this exterior angle formed by the extension of this side back to the other side of the quad. Okay, interior, so go back to the interior, and then the opposite. Those two angles are equal. Okay? So, let's work on a proof. Bless you. Right. How are we going to prove it?
The line coming out the one side and the other side are both going to equal 180.
Good. Yep, so using the property we've just done, this must equal 180, take away that, and then angle sum of on a straight line are supplementary, so therefore that must equal that. Right, so let's start it. So let angle ABC, better to work with letters rather than angles ABC. Okay, means that's right. Alright, so what that will mean, angle ADC going to be 180 take away x. 180 degrees take away x. Okay, and your reason? Opposite angles in a cyclic quad are supplementary. ARY. Okay, then angle CDE, so now we're going to that exterior. It's going to be 180 degrees. Take away the angle on the other side of that vertex, which is 180, take away X. Okay, you need to make sure you are stating a reason each time you show something. So this reason will be angles on straight line are supplementary. Alright, so let's tidy it up. So expand, so 180, take away 180, and then a negative gives positive. And of course 180 take away 180 is 0, 0 plus x, which is x. So therefore angle ABC equals angle CDE. Therefore, exterior the exterior angle of a cyclic quad is equal to interior opposite angle. Okay, so that was a much more straightforward proof there, hopefully. But you had to know the property of opposite angles of a cyclic quad are equal. Okay, any questions? Right, so there's only those two proofs. You've got two questions, and then you've got around about half hour to get some work done.
When does this get hard?
Um,
When does this get hard? This
Hard?
something's
Oh, this is easy, is it?
Yeah, this is easy so far, but you're gonna do
When?
something really crazy.
The hard bit is trying to remember all.
Yes. This is when you
Soon. Don't you worry about that. Like I said, your deductive, your proving, deductive reasoning is when they tie all these things together. You have to know all these properties and then use a certain number of them to prove certain things are happening inside circles and etc. So yeah, it's coming, don't you worry about that. Alright, so we're up to the question. Alright, example on page 101. Alright, so A, what's the value of M and N?
115. No, that's 115 take 180 take by 115.
Better.
And then
Right. Good. So M will equal 180 take away the opposite angle, and N will equal 115 take away. 180 take away the opposite angle there. All right. So remember opposite, not on the same, sharing the same interval. They've got to be opposite. All right, I'll start on this side. Okay. So example. So M is going to be 180 take away 80, which is 100 degrees, and N equals 180 take away 115 degrees, 120 and 60, maybe 60. Right, so I've been saying this every time. You need to state your reasons, please. The questions in your exercise is not asking you to do that. However, I am asking you to do that, okay? So when you get up to the harder stuff, Robin, it'll be much easier, all right? So make sure you do that. So you need to say opposite. Opposite angle of cyclic quad are supplementary. Okay. Okay, so note how I've answered both M and N and then I stated the reason. Okay, so if it's the same reason each time, you just state at the end. But we're marking you on your reasoning skills, not just the value of your letters, okay?
No, I can't. I can't.
Right, so B, so we need to find the angle of CDE. CDE, that angle there. And angle ABC.
Angle.
125.
Good, why?
Because of the cyclic, exterior angle of the cyclic quad is equal to the interior angle.
For which angle are you referring to?
CDE.
No.
What?
No.
That's literally what we did in 1910.
Angle ABC.
CDE.
She's correct, the angle CDE is 145. I'm not sure where she saw the cyclic quad to be able to do that.
No, the exterior angle.
Of?
Oh, there's not a cyclic quad, but the exterior angle.
There is a cyclic
D-
Triangle?
ABCD.
Oh.
Look.
The triangle you're referring to?
Please.
I can see it, I just can't explain it.
It's 1910.
Oh, so there, those
The
two.
exterior angle, yeah.
So those two are supplementary.
Because
DAC.
AD.
Okay, your quad is ABCD. That is your quad. Okay. However, angle OAC is 55. So Michaela is correct. In angle CDE is 145. But I'm not sure whether the reasoning is clear. That's all.
So angle ADC is supplementary to angle DAC. And then EDC is supplementary to what ADC?
So that's the other fascinating thing about this topic, because there's more than one approach. You can do a lot of question. Okay, for those people who can't quite see it, we have the triangle ACD. Alright, now the exterior angle also works with the triangle, but it must equal the two opposite interior angles. So it must equal that, and it also must equal the angle here. Can you tell me what the angle here is going to be?
55 degrees because they're opposite.
What do we have at AD?
In the cyclic,
What do we have at AD?
same
Hey?
That second line that was funny.
Yeah, exactly. Exactly.
Oh, wait, angle AC would be half.
What part of the circle is AD?
One.
Which is called a?
But
It's a chord that goes through the centre, so it is a diameter. Yes, so from that, what is the angle at here?
From ACD
Hey?
to ACD.
At ACD, yeah.
Yeah. Oh, wait, okay, that's not applicable.
Why?
Oh.
Is it because it's on the diameter?
O is 180 degrees.
Okay, a couple of things. We did this, okay, we did prove this. That angle in a semicircle is 90 degree.
X equals 2x.
Okay.
AD is 2x, and then ACD is x. So it's half of 180.
Oh, goodness. Alright. Alright, so this is one way you can do it. Let's say that. Alright, so angle. Angle ACD is going to be 90 degrees. Okay, so it is either angle at centre is twice the angle at circumference because you've got the two radii. Okay, or more specifically, okay, angle in semicircle is 90 degrees.
Go that way.
I don't know where the box is. Mr. Kitchen's bathroom, showing your floppy hands, you silly boy. Alright, so angle CDE must equal 90 plus 55, 145 degree. So exterior Yep.
Are we having a meeting at recess or is it just after school?
after school, after sport. Equal interior, sorry, equal sum of okay, so the exterior angle of a triangle is the sum of the two interior opposite angles. Okay, so I was able to find the angle ACD by using that property and then add those two angles together, and that gives me the angle out there. Right, so ABC. So this angle here, 145, we need to now ABC. So what is the size of that angle and why?
Take away this. It's going to be what D is. B's going to be D.
It's going to be 45.
Is B
45
D?
and not.
No, D is going to be, B is going to be 2 of D.
Nope.
No.
Okay, we're now showing the angle ABC. What's the value of that one? So we're just showing this angle is 145. We have the cyclic quad A, B, C, D, and then we have the exterior out here. Right, so what does this angle here must be equal to? What other angle in the diagram? Okay, well using the property we just done, the exterior angle of a cyclic quad, so we've got the cyclic quad A, B, C, D, okay, ignoring that line there, is equal to the interior opposite angle.
Wait, so is CDE equal to B?
Pardon?
CDE is
Yeah.
equal to B. Okay.
Yes. Right, let's have a look. Right, let's draw it. Okay, so one of the best things you can do this topic is actually drawing diagrams. Redrawing stuff and not drawing everything. So let's pick a point C here. Got a point B. Oh no, sorry. Yep, let me do it again.
What?
I'm sorry. Right. Do it again.
That's a good circle.
I know. Easy practice. Right, so we've got that line there. We've got the semicircle. No. This point here, there, and there. Alright, so I've redrawn it without that interval there. Alright, so this is A, B, C, and D. This is E. We've just shown this angle here is 145 degrees. Okay, so A, B, C, D is a cyclic quad because you have 4 points on the circumference joined up. Okay, any 4 points will make a cyclic quad for you. Right, so the exterior angle of a cyclic quad, so when you extend a side back with the side here, is equal to the interior opposite angle. Okay, so that means this angle will be exactly the same as that angle. Alright, so angle A, B, C is going to be the same, 145 degree. And the reason, exterior, degree. Exterior angle of cyclic quad is equal to interior opposite. Angle.
Is there a way we can write that? Is there a shorter way we can write these things?
Okay.
Maths.
One thing I was going to tell you, but I guess now's a good time to bring it up. Your HSC markers, and myself included, are very picky at your reasoning skills. Okay. Right, so it's not just enough to state the value, you need to also state the reason. Okay, and your reason needs to be clear. Because the last thing you want is to have a HSC marker who do not know you at all, okay, and therefore has no connection with you at all and want to give you marks for everything that you can do, okay, to make sure you give them all the good reasons as to why they should give you marks for the question. Right, so that's 9.3. Right, so you've got about 18 minutes, a bit longer than I thought. Right, does anyone have any questions in general? Now it's asking. Otherwise I am finished.